Hi guys, welcome back to the Tutor Learning Center. This is JD Tutor, and I'm here to teach you on the 14th video more about the distributive method. We're going to call this the distributive method extended, or the distribution method, however you want to say that. So we're going to use the distributive method and apply previous knowledge that we've learned already from other videos into what we have here. So let's look at number one. I already have number one, the answer for you. It's going to be x equals 3. The whole goal is to get the x by itself and what it is equal to. All right, so let's see how we got to that x equals 3. So let's do 3 times x plus 2 equals 15. And remember, guys, two objects next to each other or a times. Don't let the parentheses fool you. Okay, so 3 times x is 3x, plus you're going to do 3 times positive 2 is positive 6 equals 15. All right, so now we're going to, does this look familiar to you on the other videos when we first started? Yes. So let's do our cancellation method there. Cancellation, cancel. That goes to 0. Bring down your 3x equals 9. And then we have to do another cancellation method because your x is still not by itself. So inverse operations, 3 times x is your multiplication. So now we're going to do your inverse operation of division and put the same 3 that's up here down here and cancel x equals 3. And that's how we got to number 1. All right, let's look at number 2. And if you're a little behind, please pause the video. I'm going to keep going here and get a little faster. As you guys grow, we can start getting faster. All right, so number 2, 2 times x plus 5 equals 24. Okay, and the same process as number 1. So 2 times x is 2x. 2 times 5 is 10. Positive 10 equals 24. And now along the way, I didn't ask on number 1, but I'll ask on number 2 here. Can you do anything with this inside the parentheses? Can you add these together? The answer is no, because they are unlike terms. You cannot add them together. But can you multiply unlike terms? Yes, as we just did, you can multiply unlike terms. Okay. Right, so 2 times x are unlike terms, 2 times 5 are like terms. You can do both, actually. All right, so let's continue our problem. All right, looks like here we are again on some familiar territory. Inverse operations, what you do to one side, you do exactly to the other side with the same exact number, the same exact sign to the other side. 2x equals 14. We still don't have x by itself, but we're going to take that 2, apply it here, and cancel x equals 7. X equals 7. All right, let's do number 3. We're going to start speeding this up a little bit. Okay. All right, number 3. X times 1 plus 5 equals 6. All right, so let me actually get this a little closer to the parentheses. All right, so don't let the variable fool you or intimidate you because it's outside of the parentheses instead of inside like the other ones. We're still going to do the same process, but let me kind of clarify. Variables are really never alone. they're always a silent one attached to the front of them. They're silent one buddy. So now that that's into perspective, let's times. Okay, 1x times 1 is 1x. 1x times positive 5 is 5x. 6. Are these like terms? Yes, they are. Yes, they are, even if you don't have that there, which you don't have to put there. They are still like terms. Silent 1x plus 5x is 6x equals 6. All right, and so now we still need to get x by itself. So we take this number and do the cancellation method. Cancel, and 6 into 6 is 1. Now we didn't have a chance to do the cancellation method here. We didn't get that option or that opportunity. Okay, it didn't provide us one. All right, so now we're going to do number 4. All right, number 4 is exactly the same as number 3. And why isn't this erasing? Exactly the same as number 3, except I put the negative sign in front of the x. Negative x 1 plus times 1 plus 5 equals 6. So guys, something I mentioned in one of the other videos, if you want to do some quick math on some simple problems like these, are these like terms? Because parentheses, after all, is the first step that you do in the order of operations in your equation, right? So are these like terms? Yes, they are like terms. So I'm just going to do this. Minus x, negative x times 6. Okay, and negative x times 6 is negative 6x equals 6. All right, and take this negative 6 and bring it out here for your inverse operations. Okay, cancel, cancel, and x equals, oops, sorry guys, negative 1. All right, x equals negative 1, and that's on number 4. Sometimes I'm concentrating too hard. Okay, talking and trying to write at the same time, making sure I give you the right information. All right, guys, so look at number 5. Look at number 5. So we're going to do, oops, we're going to do 2x. We have a number and a variable this time. Oops, 2x, excuse me, guys. Oh, hold on, guys. Not doing too good in the whiteboard department here. Let's see. All right, so 1 minus 5 equals 4. All right, now distributive method, or we can just do 2x. And are these like terms? Yes, we can do negative 4 equals 4. Okay, and 2 times x, 2x, 2 times x, but 2x times negative 4 is going to be negative 8x equals 4. All right, and take this number, negative 8, and apply it to both sides. Cancel, and x equals, we can't divide these or else we're going to get a decimal. So, but we can simplify. We can simplify this into 1/2. So, and also don't forget your signs. Negative into positive is a negative. So x equals negative 1/2. Let's look at number 6. Okay, number 6. Negative times 1x plus 7 equals 14. All right, guys. So some students, they have trouble figuring this out, but it's because of the negative sign, but it's actually quite easy. There is a silent 1 right in there. That's going to put everything into perspective. So negative 1 times 1x is negative 1x. And then negative 1 times 7 is negative 7 equals 14. All right, this is familiar territory right here, isn't it? So inverse operations, and cancel. Negative 1x equals 21. We have to get x by itself. Now remember, this was a silent 1, right? I'm going to show you what it looks like without the silent 1, because that's how it's going to be presented in your course material. All right, so negative 1 and negative 1 to both sides. We're getting that negative 1 right here. So applying it here and here, cancel, x equals 1 into 21 is 21, and a negative into a positive is a negative. So your answer is going to be x equals negative 21. So in your course material, everything is going to look like this. Everything is going to look like that. All right, without the silent 1. All right, so you probably should get used to seeing it like that. Okay, so now we're going to look at number 7. All right, number 7. All right, for times x minus 5 equals 20. All right, 4 times x is 4x. 4 times negative 5 is negative 20 equals 20. All right, guys, don't work ahead of me, because some of you are thinking, as the past students have, all right, you're thinking, I'm just going to move this over here and cancel out this 20 with this 20. It doesn't work that way, guys. So wait for me to explain this to you, because it's not going to work out that way. Okay. All right. So let's do our inverse operations. You can cancel this out, but you can't cancel this, because that's adding both of those. So 4x equals 40, but we still have a 4 attached to that x. So I ran out of room. So I'm going to put it over here. This is all familiar territory now. Divide by that 4, positive 4, positive 4, and cancel, x equals 10. So our answer is x equals 10. All right, number 8. And don't forget, guys, pause the video if you're behind, okay? So number 8. So now that we know we can have fractions here, and those fractions can be positive or they can be negative. All right, let's look at another one. Let's look at number 8 here. Oops. 33 equals 7 times 4r minus 9. All right. Just because they reverse the order does not mean we reverse what we're doing. So we do the same process. If it makes you feel any better, you can look at it this way. Oops, it's supposed to be parentheses. All right. All right. So you can look at it that way. It's the same thing. So, but we're going to get used to doing it how they want to do it. All right. So let's do 33 equals 7 times 4 is 28R. And 7 times minus 9, -9 is -63. Okay. And what you do to one side, you do to both sides. Our inverse operations, because we want to get this R by itself. That's our aim. So what you do to one side, you do to the other side. Cancel, cancel, and then come over here and we have 96 equals 28R. All right, and we still have to get this R by itself because the 28 is attached to there. Okay, that's my dog in the background. Sorry about that, guys. We're on holiday, so I'm the only one here. All right, so divide by the 28R. I almost made that mistake and put 96 there. See, so we all have to be careful, right? Okay, 28R. All right. Let's see. Oh, I'm sorry. We don't need the R there or there. All right, and cancel, cancel, and R equals what? We actually can simplify this into 7/24. Okay, so 24/7, excuse me, 24/7. Okay, and I'm not asking for a decimal or a mixed number or anything. So we're just going to leave it at that. R equals 24/7. All right, guys. Okay, so that should be it for the first part of the distributive method extended. Get ready for part 2. It's going to be really extended. All right, guys. Thank you for watching. Stay tuned on video 15.